All right, we'll start off on number 1 here. So for this one, to find the x-intercepts, we set y equal to 0 and solve for x. And so that's kind of the key here for these, is to set the other variable equal to 0. So for this one, number 1a, I'm going to set y into 0, and then I'm going to solve for x. And so 0 equals x plus 3, so x would equal then negative 3. And so same idea for y, you're going to turn x equal to 0 and then solve for y. All right, next up we're going to use our circle formula, and so the center of the circle is always these two numbers, but they're always switched, so this is going to be positive 2 comma positive 4. And then this one always represents r squared, so that would mean that the radius is actually 4. All right, next up here we're going to find the distance, and so distance, I always just think of it as Pythagorean theorem. So if you kind of think of this as a right triangle, this is 2, and then this is 5, and so we do 2 squared plus 5 squared equals c squared, and we will just square root that to find out what c is. So that's going to go right there. You can leave it as a radical. For the midpoint formula, I just think of that as the average of the two x's, and so I'm going to add the two x's up and then divide them by 2, and then the average of the y's. So the x's, I have 0, 2, and then 5, 0, so the average of the x's would be 0 plus 5, and then the average of the y's would be 2 plus 0. And so if you just kind of figure those out, that's going to be your answer right there. Oh, you can see they already have the parentheses for you, so don't include that in your answer. All right, next up we got to find the area of this triangle. And so for area of a triangle, we can use 1/2 base times height. And we need two sides that are perpendicular. So I am going to use this as my base. And then for my height, I can actually draw a line out there and make that the height, since it is perpendicular to the base. And so I know my height then is 3. My base is 2, 4, 6, 8. So that's 8. So 1/2, 8 times 3. All right, next up here, we'll plot these points. So we got 5, 0, 10, 0, and 6, 5. And then 9, 5. All right, so then we'll draw that shape right there as best we can, and to me that looks like a trapezoid. And so for the area of a trapezoid, the formula is, I think of it as base times height, except there's kind of two bases here. There's B1 and B2. So what we need to do is we need to take the average of those two bases, so that's the average, and then multiply that by the height. So for me, it looks like the bottom base there is 5, and then the top base is only 3, and then the height is 5. So you just multiply that to find the area. All right, next up here it says that 1, 9 is the midpoint of segment AB, and so what they're kind of saying here is that I have, I'll just kind of draw this out to help visualize it. So A is negative 3, 7. I'll draw that there. And then that's connected somewhere else where the midpoint is 1, 9. And so I would say that kind of the other point should be out here, since that's kind of the midpoint here. And so what I would say then is that I know that this one will be like some x1, x2. No, actually, y1, excuse me. And so I know that if I average out negative 3 and x1, that should give me 1. And I know that if I average out, let's see, 7 and whatever y1 is, that should give me that 9 midpoint. So I'm not finding the midpoint with the 1, 9. The 1, 9 is kind of my answer, and I'm solving backwards for the other one. So you just solve that. I would start off by multiplying both of those by 2 and just isolating x1 and y1, and that's going to go in here. All right, so next up here we're finding some more intercepts. So remember, for intercepts we always plug in 0 for the other variable. So for the first one here, for x-intercepts, I would plug in 0 for y. And so that just turns into this whole thing into 0. And so I would, kind of cross that off, and then we're going to divide both sides by 4. And we get x squared equals 25, and then we would square root it, so x equals plus or minus 25. Actually, not 25, just 5. All right, so then obviously the smaller one's negative 5, and the big one's positive 5. So then for the y-intercept, but they need this as a point, so I'm going to put this as comma 0. Since I plugged in 0 for y, that's going to be my y values. Okay, so then for my x values, my my y-intercept, I'm going to plug in 0 for x, so it's going to turn this whole first thing into 0. Let's see, equals 100. So then that's gone. I'm going to divide by negative 25. So then y squared equals negative 4. And then if you square root that, it's imaginary. It's plus or minus 2i, if you wanted to actually think about it. But those are not actually y-intercepts. It actually does not hit the y-axis, so this is going to be a DNE. All right, next up here, the center and the radius. And so the center is going to be the opposite of the x and y values in there, so it'll be negative 2 comma 3. And then the radius will be the square root of the number outside, so that's going to be 5, since this really represents r squared. And so negative 2 comma 3, it looks like the only one with that center is this one. And then is the radius also 5? Well, I would say that it is, because this point's at 3 comma 3, and then this point is at negative 2 comma 3. So you can see that horizontal distance there as 5. I could have done that with any point around there. All right, next up here, I'm just going to follow my formula. So it's going to be x plus 1 squared. I got to switch that, plus, and then again, switch that y value. And then I'm going to put 81 out here because I have to square that. Square the radius. All right, next up here, I kind of know that the center here, I could write this as x plus 2 squared plus y minus 8 squared equals r squared. And then to find the radius, there's a couple of different ways you can do it. You could use distance formula between these 2 points. I like to just plug that point in as an x comma y. So I'll do that. So I get 4 plus 225 equals r squared. And so I know that r squared equals 229. So I could square root that to find out what the radius is, but I can actually instead just go back to this original form, and instead of r squared, I'm just going to plug in the 229. And so that would be my final answer then. All right, next up for number 12. So with this one, I always like to graph these, just kind of get a little visual of where we're at. So negative 2 comma 2, and then 3, 4, 5, 6, comma 8. All right. And so that's the endpoints of a diameter. And so I know that the center is going to be right in between those two. So I'm actually going to do a midpoint formula for this. And so we will just do the average of the x's and then the average of the y's. So that would be 4 over 2. So actually I'll just write that as 2 comma 5. All right. And that looks like that's about where it's at. It's a reasonable answer. I didn't draw my drawing perfectly. So then now what I'll do is I need to find the radius here. And so for the radius, I'm going to use distance formula. So I'm going to find this diagonal distance. So I'm going to draw a right triangle. So from 2 to 6 would be a distance of 4. And from 5 to 8 would be a distance of 3. And then we can use Pythagorean theorem. I actually see that this is a 3, 4, 5 right triangle. So I'm just going to label that as 5. And so then I know that the radius is 5. And so I can write my answer as x minus 2 squared plus y minus 5 squared equals 25, since that one is r squared. All right, next up we have to solve this absolute value inequality. So first thing I'm going to do is isolate the absolute value. We'll subtract the 9. And then we have to divide by negative 1 to totally isolate it. So we get absolute value of 2x minus 3 is less than or equal to 4. I do need to flip that since I divided by negative there. And now we split it up into 2. One of them I just kind of get rid of the absolute values. And then one of them I change everything outside the absolute value and nothing inside. And so 2x is less than or equal to 7. X is less than or equal to 7 over 2. On this one, I got 2x is greater than or equal to negative 1. X is greater than or equal to negative 1/2. I always like to draw these on the number line to visualize it, because sometimes they're pointing at each other and sometimes they're pointing away. In this one, I can see that they're pointing at each other, so that would be negative 1/2 to 7 over 2. All right, next up, number 15. So for this one, we want to solve this one, so we're just going to isolate the absolute value here. So I'm going to subtract 6. So 3 times the absolute value of x plus 9 is greater than -1. And then I'll divide by 3. So absolute value of x plus 9 is greater than -1/3. And I'm actually going to stop right there because right away I noticed that it's saying that we have an absolute value that's greater than a negative. And since an absolute value is always positive, that's going to be negative infinity to infinity. If it would have said less than a negative, I would have said that that's no solution. So anytime you have an absolute value with a negative on the other side, got to be kind of aware of that because it's going to be kind of a unique solution there. It's going to be a special case. All right, next up here, we have a nonlinear inequality. We have two fractions, and so we're going to have to, first of all, get one side to 0, which is actually already done for us. And so next up, we are going to get a common denominator here. So I'll multiply this one by x plus 4, multiply that one by x plus 1. And so this will become x plus 4 plus x plus 1 all over x plus 1 times x plus 4. And that's going to be less than or equal to 0. So now I'll combine like terms up top, so we get 2x plus 5 over x plus 1, x plus 4, less than or equal to 0. And then what we got next is we are going to do what? Okay, yeah, we're going to set each of these equal to 0 and put those numbers on our number line. So I got a -4, I got -1, and then for this one, it'll be -5 over 2, which is -2.5, which would be right there in the middle. 5 over 2, excuse me. Okay, now, the -5 over 2 is going to be a closed dot because of the or equals to, but -4 and -1 are going to be open dots because they're coming from the denominator. So anytime we got a number that's coming from the denominator, that's always going to be an open dot because it's an undefined value. Okay, so now I need to plug some numbers in here, so I need to test out. I'll try x equals -5, and that actually I can see really quickly will make everything negative, and so 3 negatives will make a negative. Then I can test out x equals -3 right here. -3 will make the top negative, but the bottom we're going to have one negative and one positive, so that's going to switch to positive. If I try out x equals -2, that will now make the top positive, but the bottom will have one negative in it, so that'll be negative. And then if I try x equals 0, that's going to make everything positive, and so that'll be a positive. All right, so I want less than 0, so I want the negative, so it'll be over here and in here. So my answer for this one would be -infinity to -4. Let's see, that's a parentheses, and then union bracket 5 over 2 comma 1. Actually, it's -1 with a parentheses. All right, next up here, this is already factored, so I'm just going to go ahead and put -3 and +8 here on the number line. Both going to be open circles. Now I'm going to do my test points, so -4. And I notice right away this one is squared, and so anytime that happens, you can go ahead and fill those out as positive, because anytime we have an even exponent, it's going to always be positive. So really I just have to test in the other one. So -4 would make it negative. Something like 0 would also make it negative, but something like 9 would make it positive. So there's my only positive zone there, and then I have negative here. So I have two negatives next to each other, but they are separated by an open circle. I do want the negatives here. So since it's separated by an open circle, I'm not allowed to combine those. If it was a closed circle, I would. And so I'm going to answer like this. You can see I'm taking that quick break there at -3. All right, I got another one here that is factored with one side at 0. So I'm going to go with just throwing these numbers on the number line. Oh, I have -3 out here. And then I got 6 over there. Okay. So these are going to be all closed dots. And then I'm going to do some test points here. So first of all, we'll try out x equals -4. Once again, I see that this first parenthesis is squared. Anytime you got a squared there, you can just make that one positive right away. We know that's always going to be positive. And I just have to test the other two that are not squared. All right, so if we test out -4, it's going to make the second parentheses negative and the third one negative as well, which will make a positive out there because two negatives. If I test out x equals -2.5, that's going to make a negative and then a positive, so that'll be negative. If I test out x equals 0, that's going to make a negative and a positive again, so that'll be another negative. And if I test out x equals 7, that's going to make a positive, positive, so that'll be a positive. Now, I want the positives here, so I'm over here and over there, but I need to keep in mind here, I got this closed circle in the middle. I have to include that in my answer. So my answer is going to be negative infinity to negative 3 with a bracket, and then a negative 2 on its own, because I don't want the intervals around there. I just want that one number. And then we're going to go from 6 to infinity. All right, next up here, it looks to me like this is kind of partially factored. One side is already 0, so that's nice, but I'm just going to finish factoring it by doing x plus 6 and x minus 6. And so that's going to then go to my number line as negative 6 and then a 0 in the middle for the 5x squared. And then we got a positive 6 out there. All these are going to be closed circles. So there we go. Okay, now we will test here. And I see that this is x squared. So once again, anytime we got that even exponent, we're going to go ahead and just throw a positive there every time. Okay. And then over here, no, that's going to be positive, okay? All right, so now here we go. We got negative 7 to start, would be a good number. And so it's going to make both of those negative, which will make a positive. We can try out x equals negative 5 here, which will be a positive and negative, so that'll be negative. I can try out 1 here, which will be a positive and negative again. And then I can try out 7 here, which would be a positive, positive. All right, so in this case, I am less than 0, so I want the negatives. So that is in here. Now, we have 2 intervals here that are connected by a closed dot. Anytime that happens, we need to combine those intervals, so it's going to be negative 6 to 6. We don't want to take a break at 0 because 0 is really part of our answer, so we want to include it, and so that's why I'm not taking a break there. I'm going ahead and going right on through. All right, next up here, nonlinear inequality. We want to get one side to 0, so I'm going to subtract the 1 over. And then we're going to factor it, so a times c here, we're going to multiply to negative 2 and add to 1, which would be positive 2 and negative 1. But I need to split up this middle term using those numbers, so 2x and negative 1x. And then we'll use our grouping. And so I can take out a 2x, which leaves me with x plus 1. And then I have to take out a negative 1 there, which also leaves me with x plus 1. All right, so then we can rewrite this as 2x minus 1 times x plus 1. And so then on our number line, we're going to have negative 1 and positive 1/2 as closed dots. And then you're going to do your test points from there. We want to be greater than or equal to 0. I'll let you guys handle that one. All right, next up here, during his major league career, Hank Aaron hit 230 more home runs than another famous baseball player. And then together they hit 1,260. Okay, so I'm going to say Hank Aaron, I'll call him H plus, and then this famous baseball player. And together they had 1,280 home runs. So I'm just going to add them together like that. That's not the order that's written in, but it's fine. That one to me is just easier. All right, so then next up we have our comparison ones. We're going to compare Hank Aaron to the other baseball player. Now Hank Aaron hit more home runs. We're going to have to add 230 to this person to get to Hank Aaron's home run total. And so then we can do a little substitution here and swap that out for H and then solve it like that. All right. Next up here, it says in a class of 25 students, the average score is 81. 7 students received a maximum score of 100. 4 students received a score of 60. What's this average on the remaining? Okay, so we know I have 25 students, so I'm just going to make a big average fraction, make it 25 down there. And then I know their average is 81, so I'm going to set that equal to 81. And then we're going to kind of break down the students up top. So I'm going to group them together in kind of 3 groups here. So we have 7 students that scored 100, so I'm going to do 7 times 100. You could do 100 plus 100 plus whatever, do that 7 times, but this is just a lot easier. So then 4 students got a 60, and then we want to know the remaining score of, the average score of the remaining students. So the remaining students, I need to group them all together. So I need to figure out how many more students there are. So we're going to do 25 minus 7 minus 4 for the students we already have. So it's really 25 minus 11. So that sounds like 14. So I'm going to put there 14x. And so now I need to solve that for x. I would start off by multiplying the 25 over to the other side. All right, next up here, it says that Phyllis invested $7,500 total into 2 accounts. So I'm just going to call this X plus Y equals 7,500. And then next up is kind of she ends up with 315 extra dollars, like the profit here. And so I'm going to equal this to 315. I'm going to do this as 0.0425 X, since that's 4 1/4, and then 0.04 Y. And so that would be my setup there. The second one, you could also, if you wanted to, you could make this 1.0425 X plus 1.04 Y. And then if you did that, you would have to equal it to 7,815. You'd have to add those two together because that's like the total amount in her account, but the 315 is just the profit. So I would do it in the kind of blue version here. So I would multiply this one by negative 0.04, put that underneath there, and just solve it. All right, next up here we have a radical equation. So we want to isolate the radical, so I'm going to subtract the 2 over. And that's going to equal x minus 7. And then we need to square both sides. But on this side, that means we're going to have to FOIL here. So x squared minus 14x plus 49. It's going to equal 9 minus x. Okay, now it's a quadratic, so I need to get one side to 0. And we need to factor. All right, so we'll multiply to 40 and add to negative 13, so that's 8 and 5, both negative. I don't need to use grouping here because we do not have an a value. So there you go, x equals 5, x equals 8. All right, so now because this original equation was a radical equation, we do have to check for extraneous solutions. This is not optional. So I'm going to go 9 minus 5 plus 2 equals 5 minus 5. And so the square root of 4 plus 2 equals 0. And that is obviously not true. So 5 is an extraneous solution. Now this doesn't mean that 8 is necessarily true. It probably is, but I have to check it anyway. Square root of 1 plus 2 equals 3. So 3 equals 3. That one does check out. So 8 would be the only answer there. All right, next up here, I would factor this one. So we're going to multiply to 56 and add to negative 15. So that'll be negative 7, negative 8. So I'm going to have, but since this is squared there, it's going to be x squared minus 7 and x squared minus 8 equals 0. So then I would solve each of those individually. X squared equals 7. And so x equals plus or minus radical 7, since I created that square root. And then x squared equals 8, so x equals plus or minus rad 8, which I would actually break that down as 2 plus or minus still 2 rad 2. All right, next up here, we're going to solve this one. I would definitely start off with a u substitution. X plus 4 to the 1, actually just make it x plus 4. So then we're going to call this 4u to the 1/2 minus 5u to the 3 over 2 plus u to the 5 over 2. So I'm going to GCF the smallest exponent, which is u to the 1/2, and that becomes 4. And all these exponents should be getting smaller since I took out a positive exponent there. So it's going to be 4 minus 5 u to the first there, because it'll be 2 over 2, plus u to the squared there, because it'll be 4 over 2. Okay, so now I'm going to, actually I'm going to rearrange this in here. So we'll call this u squared minus 5u plus 4. And then I can factor that, negative 4, negative 1. So u minus 4, u minus 1. And then I can plug in my u's back in. So I get x plus 4 to the 1/2 power times x plus 4 minus 4 times x plus 4 minus 1. So this will become just x, and this will become x plus 3. And this will become x plus 4 to the 1/2. All right, now this one is not a factoring problem, it's a solving problem. So I need to set these all equal to 0 and solve them. So if I say for the first one, the square root, since x plus 4 to the 1/2 is really square root of x plus 4 equals 0. I can square both sides, I get x equals negative 4. And then the middle one, I can just say x equals 0. Because that's just an x in there. And then I could say x plus 3 equals 0, which means x equals negative 3. Let's see, these are, you have to kind of look back here at these guys in the original equation. Those are all radicals, so I do need to check all these and make sure they don't make the inside of a radical 0 or negative. But as I plug those in, none of those make the inside negative, so I'm good. All right, next up here, we're solving this one. We want to get one side to 0 and factor. So I'm gonna move that that 24 piece over, and then we are going to factor out the smallest exponent, which would be negative 3 over 2 power. That's going to make all the exponents bigger. That's going to raise that one to squared. It's going to make that one an x, and then it's going to make that one a 24. All right, and so then I can refactor the inside there. It's going to be x plus 6, x minus 4. And so I can set all of these equal to 0. This one right here is really 1 over x to the 3 over 2 power equals 0. Now, normally, that gives us a solution of 0 whenever we have a GCF like that. But when it's a negative exponent and it's really on bottom, I would think of this as an extraneous solution because it's 0 in the denominator, so I'm not going to include that. So this one will give me x equals negative 6, and then this one will give me x equals positive 4. However, if we look back at the original, this said x to the 1/2, for example, the first one, or any one of those. And so this one would be, so let's say the square root of negative 6 to start. And that's actually also going to be an extraneous solution, since the original equation, that was a radical. So actually 4 is going to be my only solution to this one. All right, next up here, I'm going to simplify this. I'm going to do a little u substitution. We'll make it 7 plus x. So then I get 4u to the 1/2 minus x times u to the negative 1/2. Over u. And so now up top, I'm going to factor out u to the negative 1/2. So that's going to become 4u minus x. And now that that is factored out front, I can move it down to the bottom. I could not move it before that. I'm going to think of this as 2 over 2. So I'm going to call this u to the 3 over 2 on bottom. And on top, I'm actually going to plug that u back in, 7 plus x. And then we got minus x. So then we'll simplify that. On bottom, I'll rewrite that as 7 plus x to the 3 over 2 power. On top, we'll call that a 4x. No, we won't. We'll call it, well, we actually will. But I'm going to call it 28 plus 4x minus x. And so that becomes 3x plus 28. All right, next up here, number 30. So for this one, we got to make little mini fractions here. So we're going to call this 4 over x squared plus 4 over y squared over 3 over x plus 3 over y. We're not allowed to move those kind of whole thing to the top and bottom. So then we're going to get a little common denominator up here. Common denominator down there. So y. Okay, so then we'll call this 4y squared plus 4x squared over x squared times y squared all over 3x plus 3y over xy. All right, now I'll multiply by the reciprocal here, xy, and then 3x plus 3y. We can cancel out one of these squareds with these guys up here. You can look at we could factor out a 4 up top, so it'll be 4 times y squared plus x squared over xy times 3x. And you could pull out a 3 as well, actually. So let's go ahead and do that and call that x plus y. But I cannot cancel anything down. I can't cancel down an x plus y because that's x squared plus y squared. I can't factor that. If it was x squared minus y squared, I could actually cancel some stuff out, but not when it's a plus. So that would just be my answer. All right, next up here, we got some more u substitution, except this one I'm going to have 2. So u equals x squared plus 5, and then I'll make y equal x minus 2. When I'm writing this as my first step, I would combine those to make that 10x times u to the 4th, y to the 4th, plus 4. I would move that to the front. U to the 5th, y to the 3rd. So now I can factor out here 2u to the 4th, y to the 3rd. And then we get 5x times y plus 2 times u. And now I can plug back in. So I got x squared plus 5 to the 4th. And then I got x minus 2 to the 3rd. And then here I got 5x, and I'll do a bracket with an x minus 2. And then plus 2 with a bracket, x squared plus 5. All right. And so we get here, it's 5x squared minus 10x. We just got to simplify in here, plus 2x squared plus 10. So then we get 5x squared. Oh, no, I got to combine that. So that would be 7x squared minus 10x plus 10. And you can check if you can factor that, multiplying to 70 and adding to negative 10. It does not work, so I'm just going to leave it like that. And then we're definitely not going to touch anything else up here. We'll leave all that. And that is it.